Bob Salerno, who's the head of our project engineering group, and a bunch of other people, environmental and whatever else you do. Drafting, yep.
Okay, so morning everybody. Nice to be here. Got a nice fresh shirt on today, so I think things are better. Bringing this topic up again, as Walt mentioned, one of the reasons I think it's a good topic is because I think a lot of our users don't understand that this is even happening. So it's good to advertise it. We put it in our O&M manual, so it's not a secret, but you don't read the O&M manual, you may not even understand that it's going on. So it's good to talk about the details on this. We'll start off down arrow, up arrow. Okay, so what we're doing is calibration drift correction. So this is a soft, software type of correction to the calibration, well, to the analyzer based on the calibration performance on a daily basis. So it's being done by the PLC. It's not an adjustment of the analyzer. It's not a physical adjustment. It's a soft one done by the PLC. So we put this into all our systems. We've been doing it for forever. I don't know, 30 years. Okay, try to get focused here. We do it on all our systems except for South Coast Air Quality Management District, because they say we've seen that, we don't like it, we don't want it. We just want the raw data. So there's a difference between raw data and calibration correction data. Obviously, we're manipulating the data a little bit, so they don't like that. So that's one exception. And then we've also had customers that say they don't like it either. They just want the raw data because everything's more simple and straightforward. And so we will take it out if you don't like it. But I think it's active in almost all of our systems as far as I understand. So the purpose of it is to adjust for minor errors in the measurements. So an analyzer, it's electronic. You've got cal gas that's under pressure and has to go up to the probe and come back down. There's lots of reasons why there's going to be analyzer drift on a daily basis. As long as that drift is very small, we can make adjustments to it and say, okay, we got a little bit of error. We're going to get rid of that error, and that we apply a formula. So that formula is going to manipulate all the data until the next calibration check occurs and a new calibration set of calibration adjustment factors is developed. So, electronic noise, slight drift. So the assumption here is if there's going to be a problem with the analyzer, for whatever reason, drift, that's going to be consistent for a period of time. So, because we're gonna take a snapshot in the morning or whenever your calibration check occurs, and that snapshot is assumed to be representative of how that analyzer is going to behave for, say, the next 24 hours. So how does it work? Basically, the PLC is doing its daily calibration checks. It runs your zero gas and span gas for your daily QA requirement, and it's going to report the error on that daily check with the raw numbers. So it's important to note that we are not going to report calibration drift data with the adjustment made. It's definitely always raw values that are reported for calibration drift. After that occurs, we then, apply the corrections for all the emissions values throughout the rest of the day. So it's a calibration check. Normally it's done automatically by the PLC on a daily basis, but if you run a manual calibration, and that means the CEMS is in service, and you run a manual cal, it will also perform this function and come up with new calibration drift correction factors. So that's an important thing to understand, because you'll see in the slide coming up, if you ever adjust the analyzer, you have to do a manual adjustment on it. Okay, so PLC drift edge. Okay, so basically what it does is it looks for drift at the 0. The anticipation is killing you, I know. Here it comes. 0 check, and then we got a span check. Come on, span check. Span check. Okay, so what we do is we've got a little depiction here. So we got true correction, true concentration of the gas. So that's your calibration gas cylinder value. That's the reference value. And then the analyzer response. So in a perfect world, you would get, you inject your 0 gas. Does this have a pointer? The top one? Ah, that's why. Okay. So, you eject 0 gas, you would get a perfect 0 response from the analyzer. You eject your span gas, you get a perfect span response from the analyzer. So that would be a 45-degree line. In reality, you do your 0 check and you get a little bit of drift there and a little bit of error on your span. So what we do is the PLC will use a slope and intercept formula to create that line, which is the true behavior of your analyzer at that point in time. And throughout the day, what it's going to do is apply the 0 here, the error here and the error up here to all the daily values, but just by subtracting these 2 lines, and becomes a formula applied to all the data. Response. Okay. So if the PLC uses, so error detected at the 0 and span points, etc. there. So all that data is going to be used, all the corrected data will be used for emissions reporting. So it goes to the CDAR, CDAR stores it in the database. So the raw values are not necessarily recorded. Do we ever record the raw values in starting to? Okay. Okay. Okay, so that would be good. That way you have a reference in case there's ever suspicions or troubleshooting on this function. So that's basically how it works and what it does. A couple of cautions we want to make a note here is we only do the calibration correction on a daily basis based on the calibration results, and it resets every day. So we're not going to make corrections and then use that corrected value to evaluate the next calibration check. If we were to do that, you would get runaway drift potentially on your analyzer, because it would just keep adjusting it back to 0, saying everything's fine, even though it's getting bigger and bigger drift every day. So we don't do that. We always use the raw values. And one other thing is we show you both values on our displays, the OIT panel and the real view. They each will have either one will have a raw value for your analyzer on emissions values and the calibration corrected value. So you can always see the difference and understand that there's how much correction is being applied. It's important not to get those confused. So when the analyzer drifts beyond its limits, your part 60 or part 75 daily QA limits, we will not apply the calibration drift correction. Basically, we say the analyzer failed, no drift correction is applied, someone has to go out there and fix the analyzer. So we're not going to try to bring it back into compliance if it's out of whack. It's 4 times, right? Just out of control. Yeah. Yeah, I thought it was out of control. I could try to confirm that. Okay, so yeah, user intervention, that's our strategy here. Anytime the analyzer is manually adjusted, the calibration check must be initiated. So this is the part that's the most important, I think, in this topic today, because it's very easy for a technician to say, my analyzer has been drifting every day a little bit, a little bit, a little bit. Now I want to adjust it. So they go out there, put it out of service, manually adjust it, and go about their day. Well, if you don't do a calibration check immediately afterwards, in service, full calibration check, it means the calibration correction factors applied to that analyzer will be from the previous cal check, not on the analyzer that's just been adjusted. I mean, not on the behavior of the analyzer after it's been adjusted. So you are applying false correction factors. So you have to do a manual check every time the analyzer is adjusted. So it could have erroneous data if that doesn't happen. Okay, so I mentioned South Coast doesn't allow it. CDC is not calibration drift correction. For part 75, if you use calibration correction, it also has to be applied to your linearity check for that, well, ongoing. So CEDAR does that automatically. You don't have to worry about it, but understand that it is being applied for the regulation. And I mentioned OITs will show both the raw and the calibration corrected data. And if you are doing troubleshooting, you put the CEMS out of service, you can see the raw values. That's kind of unnecessary now because we show both the raw values and the corrected values anyway, but it will turn the calibration correction off from the PLC for troubleshooting if you're out of service. Yes. I don't think so. I mean, do we do that on the CJs? You know, you'll have to check on that one too. I mean, since it's a part 75 requirement, I would think we're not, but maybe we are. Walt or offhand? Okay, good question. I'll have to check. Okay, some other considerations here is when troubleshooting or just looking at data, you might notice that on the DOS computer, you've got a value of some value of NOx 3.2, but you go into the shelter, or if you're in the shelter, you can see that the analyzer is only reading 2.8. So you're saying, well, why are we reporting 3.2 when the analyzer's saying 2.8? Well, it's because of calibration correction. So you have to understand that there is a difference. If you really want to do some troubleshooting on the analyzer to find out what value is going to the PLC, we do have these test jacks on our systems. So you can put a voltmeter onto the test jacks and see exactly what values are coming out of the analyzer going to the PLC. So if you're ever questioning how this correction is happening, if it's makes sense or not, you can verify what the analyzer is actually telling you using the test jacks. So just one other note is calibration correction is not the same as analyzer self-adjustment. Most analyzers, I think all analyzers, except maybe Rosemount, the old ones, have the ability to self-correct. So usually have to plumb in zero and span gas directly to the analyzer, press a button on the analyzer, it'll measure its zero and span and zero off all the error so that it's a perfect behaving analyzer. We generally don't use that in CiSCO CEMS. We've had a few requests for that by customers. We try to discourage it, and usually they don't stick with it even after they ask for it, because it's better to adjust the analyzer manually. Bottom line here is you want your technicians to know how the analyzer is behaving, how often it needs to be adjusted. That tells you the state of the analyzer. So we don't That has nothing to do with calibration correction that we're doing. It's a soft correction. And that is it.